welcome back to part 3 regarding the new tool AutoSegment on Genetic Affairs website. Now, I am your host, Connie Knox. If you are not aware, this is a 3-part series on how to use geneticAffairs.com for your DNA research. We're going to continue the conversation with Evert-Jan Blom, the founder of Genetic Affairs, right now.
All right. Now the last section of our presentations tells a bit the story about AutoSegment, which is the new tool, which is actually, if people have noticed the triangulation segments from 23andMe, it is a bit similar to that approach. So it organizes your matches using overlapping segment clusters. So if you have matches that actually share a segment, it uses that information from a clustering. And I will first show you a quick example how it looks like, and then I will go into the slides telling you more how this is done. The nice thing about this tool is that it employs the locally downloaded segment file, so there's no scraping. The website does not need any credentials. You just need to register, and also it works from MyHeritage, which was not possible to do clustering for MyHeritage, and it works for 23andMe, FamilyTreeDNA, and also for GenMatch. There's one disclaimer. It needs some follow-up analysis because we're looking at files, so flat segment files, so the tool cannot always know which segments are triangulating and which are not.
Question.
Yeah.
When you started to talk about that, it dawned on me when your software is pulling data from the other services, does it automatically update when you log back in, or do you have to like update it once? You got to go say, hey, go get more data once in a while because there's new matches out there or whatever?
Yeah, very good question. So the AutoScan tool, and I haven't even discussed that because it's not that used so much anymore. So that was more like a tool to inform you about new matches. So that helps you if you have like 20 profiles, which you don't want to check every week. That tool will check those profiles and tell you if you have a new match, but it won't do any follow-up analysis. So you will have to do that yourself. So what I typically have is I get a new match, a nice match, and then I go to my website and I do a follow-up analysis. And I would like to know where this particular match is located in which tree or which cluster. So that's how I usually work. All right, so let's show a AutoSegment example from MyHeritage. So this is an AutoSegment analysis based on segments based on data DNA matches of 600 until 80 Centimorgan. Since I'm from Europe, I have to take a much lower Centimorgan threshold. If you have, although MyHeritage of course has more European matches, but typically people from the US can take higher Centimorgan matches because they have more matches within a higher range. And for this particular analysis, I took segments that should share, so that should overlap with 18 Centimorgans. So only 18 Centimorgans and higher. So you get all kind of information about how many matches that you were in your CSV files, and you upload a DNA match file containing your DNA matches and your segments. Some other statistics, and let's focus on the third red cluster. So that's the cluster that is completely connected. So if you click on that on the table underneath, you will get information about the chromosome, where on the chromosomes this segment is located, and you can see that it is located on chromosome 13. It's one segment, and if you then go down, you come into a table which shows you which segments are linked to this particular cluster. So this is one segment cluster containing 6 segments. So if you now look, you see information about the positions, and I will go into more detail later on, but this is just to show you that this is a single segment cluster. You can see that they are overlapping quite nicely in the segment representation. You see those bars here, and the SNPs and the name on the Centimorgans. And if you now, of course, I took a very nice example, but if you would take this example, you would go to the MyHeritage chromosome browser, and you would fill in those names that are linked to these segments, and you would see if to check if they are on the same site. Voila, these all triangulate. So this is
Fantastic.
sometimes it does not show this. So on MyHeritage it's very easy, right? Because it shows you the box around the segments, which shows you that so that they are triangulating, which is fantastic. Sometimes you don't get the box, but if you then remove one or two, and you can usually tell which ones are not that nicely overlapping, then certainly you get the box, and then you know that these, the ones that are left, that are overlapping. So this is, in a nutshell, very quickly, how this auto segment tool works. And now we will go into the details. So first, let's go back to our regular AutoCluster clustering. So using in common with our shared match cluster. So all of the clusters that we showed before, they typically only use shared match data to do the clustering, right? So you would have the clustering results and some gray cells. So let's focus on this particular cluster in the lower right. So this is based on shared matches. So all of those matches that are all the matches that are in this cluster, they also share DNA with each other. So, and this is a red cluster from FamilyTreeDNA. So let's check the shared segments with matches using the FamilyTreeDNA chromosome browser. I think you asked it before, right? How does it work with the segment sharing with matches? And now we can see what's under the hood. So which matches are shared. So if we look at the chromosome browser, we see this. So these are all of the matches within this cluster. And if you look closely, you can see that there are only a couple of segments that are shared by a couple of matches. So you see at chromosome 7, a couple of 2 segments that are shared by 2 matches on chromosome 19, but the others are all scattered across the chromosomes.
So they don't triangulate.
Precisely. Only some matches have overlapping segments, so only the ones on chromosome 7 and 19. And this is quite typical because you wouldn't expect that all, especially if you have those clusters with a common ancestor which is pretty far, so you're having like 4 cousins, you wouldn't expect that all of those 4 cousins share the same segments. It's just statistically not possible that it is always the case.
So let me quick question. So from a family history standpoint, why is it important to have these triangulations?
That's a good question. It gives a little bit more validity, of course, to the segments in question, and you can do some more tricks with the if you know the triangulated segment, you can also use that for additional analysis. So, for instance, you can use this information to visualize in DNA Painter. And if you find a common ancestor, you have a segment that you can link to this particular common ancestor. And if you then get a new match that overlaps with this particular segment, you can really quickly make new hypotheses because you already have established that this particular match, so this particular segment is linked to a particular common ancestor. So that makes it much easier.
Thank you.
Yeah. So for instance, if you compare a shared match clustering from MyHeritage versus a shared segments clustering. So at the left, we have our AutoCluster analysis. So you can see by the colors, and we see some gray cells. And at the right, we also see, we see the clustering results based on segments. So it more or less looks the same, but they usually look a bit more clean. So these are usually more clean results. So the AutoCluster DNA matches in a cluster do not always share the same segment, like I showed you in the FamilyTreeDNA chromosome browser. And AutoSegment DNA matches could share one or more segments. And I put could in there because you still have to do the follow-up analysis to make sure that they are triangulating. So it's, of course, if they are overlapping, there's a high probability that they will triangulate, but you have to make sure that it is also triangulating by doing this checkup. So that's the difference between doing a clustering based on shared match data and doing a clustering based on segments.
Okay.
All right, so now how do we do the shared segments? So this is getting a bit more technical. So this is more, how do we determine those overlapping segments? So typically, if you do an AutoSegment analysis, you again define a Centimorgan range. So you define, for instance, matches between 400 and 20 Centimorgan, and segments that should overlap with a minimum segment overlap. So, for instance, segments that share at least 10 Centimorgan. So that's the first step. So you specify the settings. So we first import the segments. So we discard all of the matches we first discard all of the matches that are outside the range. So everything above 400 and everything below 20. And we also discard segments that are smaller than 10 because they will never reach the criteria of having 10 centimorgan overlap for it. So they are discarded. And then we compare every segment to every segment in our database. So if you have a segment of 15 centimorgan, for instance, the first segment A, and we have a segment B, if they have an overlap, we calculate the overlap with a genetic map. If that overlap is the same or higher as the minimum defined overlap, we keep it. However, we also check if they are on the same site, if this information is available. So sometimes if you've tested close relatives on FamilyTreeDNA or 23andMe, you get information about the paternal or maternal side. So this is information from my FamilyTreeDNA because I've tested both my parents. I also get information about matches that are from one side or the other. So if this information is available, it will only link segments that are on the same side. So only paternal with paternal or maternal with maternal. So this is information for FamilyTreeDNA and 23andMe. Or if you could also add this information yourself to the files that you download from the website. So if you have MyHeritage data, you could add this information yourself if you already know beforehand that certain segments are from one side.
Very cool.
So to conclude, so we have a segment which is overlap, which is larger than the minimum overlap. They are on the same site. We link them. And for GEDmatch, we introduce another criteria because from GEDmatch we download the triangulated data. So we have a specific download from GEDmatch that takes the triangulated data. So that's another criteria. So after linking all of the overlapping segments, we identify segment clusters, and we do this very stringent. So we only want clusters that are fully connected. So all segments should match each other. So if you go back to the segment cluster over here, so this is a cluster that is fully connected. See, everything is overlapping with each other.
Okay, here's a wild question.
Yes.
I don't know if you can answer this or not. Have they been able to identify certain segments of certain chromosomes, I guess, to identify with certain traits like hair color, eye color?
They have.
So if you've got multiple people, I'm going to make this up because I don't really know. If you have multiple cousins who are overlapping on the same segment at the same place, so they're triangulating, and let's say that particular chromosome represents, or that part of that chromosome represents hair color, theoretically they all would have the same hair color?
Yes, if it would be as simple as that, yes. But most traits have really depending on multiple variations or multiple SNPs or multiple pieces of the genome.
So it's not that simple to just take one piece to make.
No, I think for hair color, because I know this because I also have red hair myself, these are usually located in a specific gene, so you could maybe extrapolate that information. I have seen cases in some, for instance, certain diseases which are very severe and dominant that are linked to a single location. It is possible to, if you have this particular trait yourself, that if you find those segments that triangulate with your segments, that you're able to make some medical conclusions for these people. That is true. That has been shown already, but it's quite limited, and it's quite limited to quite severe things. If you come into the more the regular things like height and eye color, stuff like that, it becomes much more work.
Yeah. Okay.
But in principle, it's for some traits and some characteristics, some medical conditions, it is possible. It's true.
I'm wondering if we'll ever be able to rebuild the DNA of our ancestors.
I think they did for Ancestry, did some time ago. They had a ancestral couple, I think in the 1800s, that had one guy had 3 wives or something and had like 10 kids with every wife. So there were many, many descendants, and they were able to reconstruct the genomes of those ancestors.
Wow.
Yeah, if you have that, of course, that's very nice, because if you could reconstruct those genomes, then you could make very, very nice predictions, right? Already.
Right.
Much better.
Very cool.
Yeah,
all right, I'll let you continue. I just didn't mean to get sideways, but you know.
All right. So we have yourself, we have these segments that you share with your DNA matches. So these are the links with your DNA matches. But some of these segments are also overlapping with each other. So some segments overlap with other segments from another DNA match. And that's how the segment clustering is actually working. So we are finding those clusters and we try to find those fully connected clusters based on fully overlapping overlapping segments. Now we're looking at how to link DNA matches. So we would like to get DNA matches. So we have to convert those segment clusters to DNA matches. So it's actually pretty easy. We take the DNA match data, so the segment data, and try to find the DNA matches underneath, and we try to come up with a regular clustering. And this is how it works. So we use the segment clusters to link DNA matches and to actually transform them into a AutoCluster format. So we assume that a match A and B are a shared match if they have a shared segment. Does that make sense? So if
Yes.
you have two matches that have overlapping segments, we assume that they will be a shared segment. It's probably true, but you have to of course check it because of the fact that it could still be on a different side of your chromosome. But for this sake, we assume that because they overlap, that they are a shared match, and we use this information to do the clustering. And so we do the clustering and we get those clusters. This clustering is not as stringent as the segment clustering. So if you remember, the segment clustering only wants fully connected clusters. We still have them in this clustering. So these are the ones that are fully connected. And these usually represent a single shared segment. If you see those clusters that are a little bit more broken up, these usually represent multiple shared segments.
That makes sense.
I have an example. So there's a summary underneath the table, which allows you to see which chromosomes are covered for these clusters, how many matches are linked to these clusters, if there are paternal or maternal matches in there already from FamilyTreeDNA or 23andMe or manually added, how many segments and how many segment clusters. And if you then click on the link, so at the left you see the links. If you click on the link, you will get the chromosome browser and see which segments are located where on the chromosome browser. And then you scroll down, you see the segment clusters linked to this cluster. So in this case, we have a orange cluster which is fully connected, which is cluster 1. You see in the red, this is cluster 1. And then there are two segment clusters linked to this orange cluster. So one is directly linked. That means that all of the members of cluster 1 are having a segment. So you see that every segment here, so the segments are located over here, are all derived from a match that is in cluster 1. These are all on chromosome 19, and these are the positions. You see that one of them is very large, and the other ones are much smaller.
Yes, I love the fact that the start and stop locations are there.
Yeah, and because this particular match that is behind this segment also has an overlap with another segment cluster, which is indirectly linked to cluster 1, because this match over here, I just know by heart, is in cluster 1, which is over here, but the other one did not overlap as nicely, apparently, with this is on a different chromosome. This is chromosome 7.
Interesting.
And just for sake of completeness, I added this as well, because sometimes you have, this is only one, but sometimes you have a whole segment cluster and only one is not in this cluster, and then it would be left out, and it would be a waste to not have this information. So this is all in here. So this is a smaller segment cluster, but it's not all of the members are linked to this orange cluster. This is getting more complicated, huh?
No, but I have a ton of follow-up questions, but you may be getting there anyway, so I'm just going to shut up and let you keep going.
Now we have this funky cluster that was not fully connected. So we had this strange lines, so it was not as nice as the other ones. So now we do have two segment clusters that are linked to this cluster number 7. And the first one is on chromosome 11. You see the segments over here. And this is match A, B, and C. They're all around 20 centimorgans, so 21, 23, 19.5. And then we have another cluster, segment cluster, that is on chromosome 13, which is from A, D, and E. So you see that A is again in here, and D and E are new. So A, if you go look at the gray cluster, is linking two segment clusters. Do you see? So A is matching both segment clusters, but it's matching those two that do not overlap with each other completely. So that's why it's not fully connected. So this is actually, if you then look at the gray cluster, it's actually composed of two smaller clusters. So this one.
Oh, I see it now. Yeah.
And now this one. So these 3 by 3 is this one, and the 2 by 2 is this one.
Interesting. I'm glad you explained that because
yeah.
It's sometimes hard to understand.
This is difficult stuff. So sometimes I also have to see it, and then I have to take some coffee and wrap my head around it. But
That's funny.
Once you get to know this information, it's getting easier. All right. One of the things is also happening with the AutoSegment tool that it's easy to pick up pile-up information. So pile-ups are sections or segments of DNA that apparently they are quite long and have been in there for ages and are difficult to link to a common ancestor. So these are piled up, like I said. So for instance, the particular cluster has 95 segments, and if you look at the positions, these are all located on chromosome 15. You see that the start is almost always the same. The length is sometimes a little bit different, but they're all overlapping. And if you compare this with some research that has been done with known pileups, you would see that they are overlapping with pileup information from a study of Lee et al. From 2014. So this is the one. So this is chromosome 15, and it's overlapping with this particular pileup region. So there's an option in AutoSegment to have the AutoSegment check those segments for known pileups and have them removed. So then you don't see them anymore.
So if I understand what you're telling me, the pileup segments are basically a bunch of miscellaneous pieces that are left over?
Well, these are they're not miscellaneous in the terms that they are all over the place. Well, that could be, but the known pileups are the ones that are having characterized apparently in the past. So the locations are known, and so the ones that are in those regions are apparently more often a pileup. And by having this information, you can remove them. That doesn't mean that if you enable this option that you don't have any pileups, because people can still have some personal pileups, like they say them. And it's possible to see those personal pileups by looking at a chart that I also create. So there's a chart that I create where I plot the number of segments per chromosome for the locations. So this allows you to assess if you have some regions in your chromosome that have much more segments than other regions. So this is still okay. But then there's apparently a region on chromosome 18 that is much higher. Again, the identification of the personal pileups is pretty difficult. It's quite subjective sometimes. So I try to come up with some objective rules, but apparently it's still difficult to get those.
I'm still a little confused. So we don't want the pileup in there. So I'm trying to make sure I understand this.
Yeah.
Right.
So what I do is I remove the known pileups. So from this study, so it's an option to get those removed. So you can tick this feature, and it will allow you to remove all of those pileups. So then you are at least so then you don't see the pileups that are already known to literature. But it's still possible to have some pileups that are specific for your data set, so that are not in this particular table. So your personal pileups, and you would easily see them because of those large segment clusters with some pieces that are all starting on the same position. So you could spot them like this, or you could look at the charts that I create, and you see them in the charts visualized like this. And again, it's a subjective way of knowing if it is a personal pileup, but these charts in those segments can help you identify them a little bit sooner. Or you can, for instance, import them into DNA Painter. You can also view them using this DNA Painter tool, and then see them there as well. There are just different ways of getting to know those pileups.
I'll have to study that one more.
Yeah. I also actually only learned about those things when I was making the AutoSegment tool, so I had to adapt my tool for this as well. We also created an Excel representation because sometimes if you have many segment clusters and many DNA matches, those HTML charts become very, very large. So now we make those Excel files, and we have the cluster colors are also represented in the first columns. Like I said, one of the things you have to be careful about is the fact that you need to do follow-up analysis of the segments, because these are all flat segment files. So I cannot detect triangulated segments. So you have to do that manually. So you have to do that yourself. That's very important. GEDmatch is the only exception because, like I said in previous slides, we employ triangulated data from GEDmatch specifically to check the segments from GEDmatch to give them some more, so have a higher probability of being right. And by having triangulation data, we know that they should triangulate. So we have the segments from GEDmatch and the triangulated data. So this is being used as an extra check. So how do you start it? So this is the link in the top. So you see here the top Centimorgan 250 is set. This is the lowest setting, so matches below the setting are discarded. This is the minimum overlap size, so this is now set to 9. The minimum cluster size, if you're only interested in large clusters, you can increase this number. Now we have the option to remove known pileups. This is AutoSegment name. This allows you to give it a name because it doesn't take it from the, it cannot know which person is behind this data set. And then you have to upload the files that are linked to your segment data. So for MyHeritage, that's the DNA match and the segments data and so on. And there's a tutorial in the top. It's not here, but it should be one link before, which allows you to know how to download these data, which is in a PDF file.
Okay.
So the max Centimorgan means, like I told you, all of the information. So this concludes the AutoSegment, and now I have a short piece about the newest tool, which was actually released last week. And
fantastic! We always like new stuff.
Yeah, this is new stuff. This is bleeding edge technology. This is the Hybrid AutoSegment, because you can imagine if you are looking at overlapping segments, it doesn't really matter where those segments are coming from, right? You can have segments from different companies. These are all the same. These are just locations on chromosomes and stop sites, and that's about it. So the Hybrid AutoSegment combines FamilyTreeDNA, 23andMe, MyHeritage, and GEDmatch. So this is an example where you see a purple cluster which has members from FamilyTreeDNA, GEDmatch, MyHeritage, all of them. So they are overlapping segments from 4 sources. Of course, we have GEDmatch data in there. So if there are GEDmatch segments that are triangulating, that are overlapping, they should triangulate. So that's an additional check for the GEDmatch data. And the principles are all the same as AutoSegment. So it's basically the same story that I told you before for AutoSegment is now also valid for Hybrid AutoSegment, with a small difference, because there is something with the FamilyTreeDNA data. So FamilyTreeDNA data is reported, so the positions are reported for a specific reference build of the human genome. So when they're making those reference builds, these are getting a certain number, so a build number. So FamilyTreeDNA is using build 36, and all of the other companies are using build 37. So for some chromosomes, that can make a difference. So for instance, I had a segment on chromosome 19, so which is in the top left, on position I think 48 million until 53 million. And this particular match was also on MyHeritage. So when I checked MyHeritage, it certainly was on position 42 million until 49 million. So there was no overlap, because I expected those matches to overlap for this segment. That's how I found out. So these two segments did not overlap at all, because FamilyTreeDNA is using a different build of their data.
Who is dictating the builds?
Well, that's probably some kind of consortia that is making those builds. And there, I think now already at 38 for some time now. So more or less all of the companies are lagging, but it's not that a big of deal because it's the higher the build, the smaller the changes are. So these are usually quite small changes, but for some chromosomes, the changes can be quite big. So for instance, 19 that I discovered myself is actually one of the most severe. So sometimes you can have a shift of around 5 centimorgan. Or in my case, I think it's even more because it's completely not overlapping at all. So that's a shift of around 10 centimorgan. But most chromosomes are fine, but there are some chromosomes that can have a small change, which then leads to no overlap.
So how do you correct for that?
So there are
You don't have like a backwards compatible tool that would take MyHeritage from 37 to 36, would you?
No, I do it also. I only correct. It is possible to do these files, so to go back, but it's much easier to only fix FamilyTreeDNA. So I do a liftover procedure and I fix the positions of FamilyTreeDNA, and then they are much better, and then certainly they overlap again.
Smart.
So after doing this liftover, I get overlap for this particular segment.
That makes sense.
Yeah. So like the auto segment, you get the information about the cluster. So this is a cluster link with chromosomes, how many how many matches. But now you also see how many FamilyTreeDNA matches, how many 23andMe matches, how many MyHeritage, how many Jet matches. So this is added to the table. And the paternal, the maternal data, the number of segment clusters, and the number of segments. So that allows you to quickly see how many segments you can expect. So if you click on it, you also see the chromosome browser. But if you go down, everything is now shown here in a large table. This is actually a table that is shown at below the main chart. So you would see the animated chart, and below you would see all of the segment clusters in a large table, because sometimes you have DNA matches that are not in the chart because they were excluded because of the fact that they were in too small cluster, or they were not clustered at all, but they could still be linked to segment clusters. So you could still trace back segment clusters to matches of interest that are left out of the chart, but are still in segment clusters. So that allows you to quickly see that. So this is the cluster in which the ones that did cluster are residing. So you can see the ones at the top were in cluster 38, 37, 39. And then underneath you have one that is not clustered at all. So this one. The match below that is in cluster 1, and then it goes on. Here you see on which how many segments are in this particular cluster. The chromosome, the start and stop. Also the overlap. I like this overlap. So this is a segment representation. I already showed it a couple of times, but it's very easy to quickly assess how large the segments are with respect to each other. So this is all relative to the segments in this particular segment cluster. And that is telling you quickly how they are overlapping.
So that visualization of the segment is similar to what you'd see on the chromosome browser, right? As far as
So because sometimes you have a very large segment and then the other ones are much smaller. If you would have to get this visual based on the start-stop information, it's almost impossible. It takes so much time. So by doing this segment representation, I take the biggest one of that segment cluster. So that's the largest min and max of the visualization, and then the other ones are all relative. So if the other one is only half, so then you see half of it visualized. So that allows you to quickly assess if the segments are all of equal size, or maybe one is very large, the other ones are very small. It just makes it easier to assess how they are compared to each other.
Yeah, like those 3 at the bottom that are similar in size.
Precisely.
Very helpful.
Yeah.
All right.
So we have the SNP count, which is sometimes also quite different. So you can see here, for instance, the top section, we have a SNP count of 23andMe that tells you it's 1329. On MyHeritage, it's almost 4,000, and on GEDmatch, it's only like 500. So it's amazing those differences between the companies. It's really striking sometimes. These are the names of the DNA matches all blurred out, and the companies where they come from, Centimorgans. And I think I didn't implement it yet, but I should. For the DNA matches for FamilyTreeDNA, I should also put in the corrected Centimorgan for FamilyTreeDNA, because they provide everything, including those 1 Centimorgan segments. But I could make a better score only taking into account the segments of 7 Centimorgan or larger.
Makes sense.
Yeah. So that would then add it to this section, the paternal and maternal. So yeah, how to start this? This is more or less the same as AutoSegment, but then all four combined. So you have the name of the analysis, the minimum overlapping segment size, if you would like to remove those known pileups, if you would like to do the liftover for FamilyTreeDNA, the minimum cluster size, and the company-specific settings. So for MyHeritage, it takes 2 files. For FamilyTreeDNA, it takes 2 files. JetMatch has 2 files. And only 23andMe has 1 file because they integrate the match data with the segments into 1 file. So that only takes one file. So this is the interface. And then I think I come to my last slide. Almost last slide is what else you can do with the auto segment data, except for apart from doing some tree building and stuff like that. You can also import those data into DNA Painter. So you can take the chart, the HTML chart, and load it directly into DNA Painter and get all of the overlapping segments at once in your profiles. And
now that's starting to rebuild the DNA of our ancestors right there, right?
yeah, of course, if you would like to continue working with your DNA Painter, it makes sense to have all of the other segments in there as well, though also the ones that do not overlap, because you could get a new match in the future that does overlap. But if you're doing a quick and dirty DNA Painter job, for instance, for an adoptee or something, you can easily import everything at once and get a good view of the overlapping segments instead of doing it all manually, because otherwise you have to do it manually using DNA Painter. So there's a specific tool for that. It's the cluster import tool, which is located underneath that link, which allows you to do so. All right, so some acknowledgement. I have a very active Facebook group on Facebook, which helps out a lot. The bloggers that do blogging about my tool, of course yourself. Patricia Coleman, which is a moderator of my Facebook group, which is really helpful testing my tools and making nice blog posts about the tool. So she has a nice site which has lots of new blog posts about the tools that I release. That's also interesting. And that's the end of the last part.
This has been fantastic.
It's a lot, right?
Oh my gosh. This is very cool.
This
Yes.
is like 2 years
And-
time into one presentation, so it's really a lot of data.
Well, I am very grateful for your time. This is really something special, and I realize that for some folks, myself included, it's going to take some additional study and rewinding the tape and watching it again and again to make sure. But wow, I can't wait to go play with it more now that I have a better understanding of how it works. So thank you.
I also have a nice manual which is recently has been updated, so that might be useful as well.
Super.
And people are invited to ask questions on the Facebook group. So
The manual, how does somebody get a hold of the manual?
this is my website.
Yep.
These are all the different tools in there: AutoSegment, AutoCluster with some information, and Auto Pedigree. From price information, frequently asked questions. If you go to frequently asked questions, I have information about ancestry, for instance, of other things. And then there is a manual.
You just went past it. Okay, good. All right. People are going to want to know how much that costs to use your tools.
Yeah. So if you become a new member, you get credits. So we use with credits because some people do one analysis every week, some do many more. So one credit is roughly the equivalent of $1. So most analyses are around 50 credits, are like 50 cents. You get 200 credits if you become a member, and that allows you to do like around 4 analyses. Some people already have enough information then, and then they leave. It's fine. If you want to have more, you can do a subscription or a single charge, and then you get more credits. So if you do a $5 subscription, you get 500 credits.
All right. Well, thank you. I know it's really late where you are, and I really appreciate you taking the time this evening to give us a very deep tour. I really appreciate it.
It has been my pleasure. Thank you for having me.
Well, that was quite a series. Thank you, EJ, for sharing all of that and for creating Genetic Affairs to begin with. If you made it all the way through all 3 episodes, I applaud you. I hope you learned something. If so, tell us what your favorite part was in the show notes below. Well, it is time to put all of that learning to work, so it is time to go find your ancestors. So until next time, keep on climbing your family tree.